Unit 4, Lesson 5, Systems of Equations, Word Problems. We're now going to take everything that we've learned and apply it in situations, real-life situations. We're going to set up equations and solve using the different strategies that we've learned to solve systems of equations in this unit. Let's start with our first problem. Number 1. This is on your paper, example 1. Or if you're doing this on your own paper, just make sure that you write out the word problem so that you can circle the numbers that are needed to solve it. The local theater sold a total of 320 adult and children tickets for $3,120. An adult ticket costs $12 and a child ticket costs $6. How many of each type of ticket did they sell? So keep in mind when solving systems of equations, we're always going to be writing two equations and then solving them, seeing where they intersect or cross, finding that ordered pair that solves both of them. All right, and most of the equations we've solved we've always used X and Y. So on word problems, you can use X and Y, or you can use different letters to represent those problems in situations in the word problem. And sometimes that helps you to make sure that you don't get them mixed up. All right, so since we know they sold a total of 300 tickets, the word total is one of our key words, means equals, and so that equals 320. What equals 320? Well, that would be adult tickets and, meaning to add, child tickets. So if we take A plus C, or you could use X plus Y, we know that's going to equal 320. So that's our first equation. A plus C equals 320. And again, you could use X and Y if you want. Just make sure you label them correctly on your paper. So the adult tickets plus the child tickets equaled a total of 320. All right, and then we also know the number here, which is our total. So I'm going to switch colors for this one because this is another total. This will be for our second equation. And then it also tells us the price. Adults are $12 and child's are $6. So there's the information that we need for our second equation. So since an adult costs $12 each, we would write that as 12A, and a child's ticket costs $6, so that'll be 6C. And we know that the total of these together equals $3,120. Now notice that I used the money total with the amount of money total for each topic. So all the money kind of goes in one equation, and the other equation is about how many tickets were sold for the total. All right, so now we can look and see that both of these equations are in standard form. So we can use our strategy of elimination to solve when they're in standard form. So we could do that by multiplying the top by 6 to make the C cancel out. It'd need to be a -6, so let's try that. So I'm going to multiply the top equation by -6. So 6 times A is -6A, and -6 times C is -6C, and then -6 times 320. I'm going to do that on my calculator. Hopefully you have your calculator out to do your math as well. And that's 1,920. All right, so I'm ready to add these two equations up. So, I'll draw my lines here. So, positive 6C and negative 6C cancel, and 12A plus -6A is a positive 6A. And then 3,120 plus, that should be a negative. Sorry, 3,120 plus negative 1,920 is 1,200. Divide by 6, and A equals 200. So that tells us that there were 200 adult tickets sold. Now we need to figure out how many children tickets were sold. So we need to take A and plug it into either of these equations. So I'm going to use the top one since it's the easier one, and I'm going to plug that in here. So that means it'll be 200 plus C equals 320. So subtract 200, and I get C equals 120. So now we know the number of child tickets that were sold. So now the last step for word problems is word problems get words. So we're going to take our answers and put them in a sentence. How many of each type of ticket did they sell? That's our question. We always come back to it, so we make sure that we're answering what they ask. All right, so the theater sold 200 adult tickets and 120 child tickets. And that's how you solve the word problem. Let's do another one. Let's do example 2. The sum of two numbers is 48. The difference of the two numbers is 4. Find the two numbers. All right, so we know our key word here, sum, means to add. That's what you, sum is the answer when you add two numbers. So we add two numbers. Is means equals 48. So we don't know the two numbers, so that's where we're going to use our x and our y. So we're going to have our first equation be an x plus y equals 48. Because we add two numbers, we get 48. The next sentence says the difference, and difference means to subtract. We know that's the answer we get to a subtraction problem. So the difference of the two numbers, which is our x and our y, is means equals 4. Okay, so we're going to do x minus y equals 4. Find the two numbers. So if we add them together, we get 48. If we subtract them, we get 4. All right, so let's solve this problem. They're both set up in standard form, so again, I would use substitution for this. You could get one of the letters by itself and use, you could get one of the letters by itself and use substitution, but since they're lined up, we can quickly do elimination also. So both methods work. You can do whichever one works for you if you want to do elimination or if you want to do substitution. I would use elimination for this one because you can easily change this to multiply by -1. Which makes this become a negative x, this becomes a positive y, and this becomes a -4. So it's quick to do some easy math here and eliminate. So let's do that. So positive x and negative x cancel. Y plus y is 2y, and 48 plus -4 is a 44. Divide by 2. And y equals 22. So we know one of our numbers is 22. Plug it back in and find the other number. So we have x plus y equals 48. I'm just going to take that 22 and plug it in for y. So x plus 22 equals 48. So I would subtract 22. And x equals 48 minus 22, which is 26. All right, so find the sum of the two numbers. Find the two numbers. The two numbers are 22 and 26. And there's our solution. Remember, the word problems get words.